Hello, Algebra 2. Welcome to Chapter 3. Hopefully you also did the factoring review and so are up on some of your factoring skills because that's going to play pretty heavy from here on out. And so I also wanted to mention that on these videos, I like the videos to be as short as possible. So if I do go too fast, realize you can always pause the video. I think you can even control the speed at which the video plays. So feel free to make the video work for you, okay? Especially when we're doing examples. You should always kind of try and do the examples on your own. So the first thing we're going to talk about is the square root method. This is going to come up when we do completing the square, but it's when you have only one squared term with x. There's no other single x in the problem. And the process is that you want to isolate the squared term. And then once you have it isolated, you're going to take the square root of both sides, and one side, usually the side with the number, the integer, will get a plus or minus in front of the square root whenever you take a square root. All right, so let's see how this works. So we notice in example 1 here, A, I only have one x and it's a squared. So I'm going to isolate it. So the first thing we're going to do is add 31 to both sides. So that gives me 4x squared equals 80. And then I'm going to still isolate, so I'm going to divide both sides by 4. So we have x squared equals 20. And at this point, we take the square root of both sides, but we immediately put a plus or minus in front of the one with the number. So that simplifies now. The square root cancels the square, so x equals plus or minus 20, but we need to simplify our radical. So this is going to be the square root of 4 times the square root of 5, because that equals 20. And we know that the square root of 4 is 2. So this is going to give me my final answer, x equals plus or minus 2 rad 5. Okay, let's try another one. And again, if you want to pause and try this one on your own, then you can kind of check your answer. So we want to isolate the squared term. Notice there is the only one squared term, so the first thing we do is divide by 2. So I have x minus 4 squared equals 18. Once again, we're going to take the square root of both sides. Sorry, my cat's going to be meowing through all this. And so then squaring and square root cancel. I have x minus 4 equals plus or minus. Now 18 can also be simplified. That's the square root of 9 times the square root of 2. Trying to put in a perfect square in there. So we have x minus 4 equals plus or minus 3 rad 2. Now we haven't solved for x yet. So x equals, we're going to add 4 to both sides, and I'm going to leave it in front because it's going to look as if we did the quadratic formula. It should have that same look to it. All right, so there's that one. And then the last one, definitely try this one on your own, but I will go ahead and get it started. So we want to isolate our squared term. So we have here 2/5 as a coefficient. So I'm going to multiply both sides by the reciprocal, which is 5/2. So that all goes away. And I have x plus 3 squared equals 25/2. All right, so we have our square root term, our squared term isolated, so we take the square root of both sides with a plus or a minus, and then this gives me just x plus 3 equals plus or minus. So when you're doing this, you can break this up into a square root on top and a square root on bottom. So I have plus or minus, the square root of 25 is 5 over the square root of 2. And if you remember, from Algebra 1, you're not allowed to have a radical in the denominator. We also did this last year in geometry when we did the trig. So you take whatever that square root is, I call that the problem child, and we multiply top and bottom. So we're multiplying by 1, but what that does when you multiply a radical times itself, that will get rid of, so I still have a plus or minus. My denominator now just becomes 2. My numerator becomes 5 rad 2, and we're almost done because we still have to isolate x. So x is going to equal, I have to subtract 3 from both sides, 3 plus or minus 5 rad 2 over 2. That will be our final answer, okay? Then we get into factoring. Okay, so this is kind of then just building on the factoring review. Remember, if you're solving by factoring, the first thing you want to do is, not what I just wrote, how do I get rid of that? I want to set the equation equal to 0. So make sure all your x's have moved over to one side. That's the first step. Second step is whatever strategy you need, whether it be guess and check. I tend to do as my first step this a times c goes on top, the middle term goes on the bottom. You're looking for factors of the a times c that add up to b, that add up to the middle term. Because that middle term is the oi in FOIL, the OI. And then after you have factored, you set each factor equal to 0 to solve, which is what we did with the intercept method. All right, so this is going to be kind of the same thing we did with the factoring review. So let's go through this, and again, if you want to pause and try these on your own, that would make it even stronger for you. So the first step is set the whole equation equal to 0. You can't factor until the whole thing's equal to 0 because you want to have the right signs in front of your numbers. So I'm going to then do my little diamond here, whatever you want to call it, crosshairs. So a times c is a negative 45, 1 times 45, negative 4 down here. So don't forget the signs in front. So what times what is 45, but adds up to a negative 4. So I know that 9 times 5, those are 4 apart. To get a sum of negative 4, the larger number has to be negative. The smaller will be positive. So that means I can now factor this, since our a value here is 1. Only when that value is 1, then these are the numbers that go into your parentheses. So x minus 9, x plus 5. Because notice, you can always check, do what I call the double rainbow. This is your OI. That gives me 5x minus 9x gives me the negative 4x. So we know we factored it correctly. So then I set this first factor equal to 0, which gives me x equals 9. Set the second factor equal to 0, x equals a negative 5. And that's going to be your solution, which, if you took the time, you could plug it back in and make sure that it works. But I think we're good to go here. Now this second one, unfortunately not all the terms are even numbers, otherwise I would do the GCF and divide everything by 2, but we didn't get that lucky. So we're going to start off and do our diamond, since everything's already set equal to 0. So a times c is going to be 24, 2 times 12. Because remember, this is a, this is b, this is c. Negative 11 goes down here. So what times what is 24 and adds up to a negative 11? They're both going to have to be negative to give me a product that's positive. So this will be a negative 8 and a negative 3. Now, I talked about on the factoring review 2 ways to do this. I'm going to do it the long way, but those of you who liked that double rainbow, I definitely recommend that as well. So I'm going to, since this adds up to negative 11, that's how we're going to rewrite this. So we have 2x squared minus 8x plus a negative 3x plus 12. So notice -8 plus a -3 is a -11. So all we're doing is rewriting the equation to begin with. Now we do what's called factor by grouping. So I'm going to group the first two terms and the last two and pull out a common factor. So I get 2x is common to both. The first term is going to still have an x in it. The second term now is going to be a 4, and you can quickly kind of distribute that to see that you did it right. The second one, I'm actually going to pull out a -3 from both. So whenever this first term here is negative, you're going to pull out a negative. So this is going to be a -3, and so that's going to leave me with just the x. So I have -3x. The second term, it's going to change this to a negative. So -3 times a -4 gave me a +12. And remember we talked about if these two are the same, you know you did it right. So the final step is to factor this out. So I have x minus 4 as one of my, that's the common factor here. What is left outside goes in the last parenthesis and set it equal to 0. So now we set each factor equal to 0. And notice when you have one of these, so we have immediately x equals 4, there'll always be a fractional answer for one of them at least. So add 3 to one side, divide by 2, there's your two solutions. All right? Now this last one is actually the easiest, but also confounds people the most, because you don't just have one squared term, you have two terms, each with an x in it. So this strategy really is just, we're going to pull out a GCF. So the GCF is just x. So we pull out an x, what's left? X minus 8, and we set each factor equal to 0. So the first one is just x equals 0. That comes out right away. X minus 8 equals 0 gives me a solution of x equals 8, and there you go. There is your solution. So in this chapter, we're going to be looking at two types of word problems that sort of build off of the same formula. If anyone has taken physics or is taking physics, you might be familiar with this. So this is not going to be throwing an object. This is just if you're standing somewhere and dropping the object off of a cliff. It can be modeled by this equation. So the height, so h represents the height with respect to time, with respect to t, which represents time, and that's going to equal -16 t squared plus what we're going to call, actually, well, I'm going to leave it as h naught. All right, so what does this mean? This -16 is in feet per second squared. It's actually your gravitational constant. So that's the speed at which something falls when you just let it go here on Earth. It would be different on a different planet. And then this h naught, the little sub-zero, actually represents at time 0. So this is your height at time equals 0, which we also call your initial height. And later on, we're going to build on this equation and put in a velocity component when you actually throw the ball. Okay, so this is the formula we're going to be working with throughout this chapter. So we have here the graph to the right can be modeled by h of t equals -16 t squared plus 200. So that 200, that's representing your initial height, kind of like your y-intercept, let t be 0. And we want to find how high is the object after 1 second. These are definitely calculator type problems. They won't always come out really pretty. But so we know here time is 1 second. So we're going to plug in 1. So h of 1 is -16 times 1 squared. Remember, 1 is the only thing we square, plus the 200. So basically that's 200 take away 16, which you can see right here, is going to be 184 feet. And because these are problems in a context, you should try and include units in your answer. How long does it take for the object to hit the ground? Okay, well, yes, they're giving us an answer here, but what if you didn't have that graph? So to hit the ground, think about what is the height of the object when it hits the ground. Well, the height of the object is 0. So you're setting your equation, your quadratic, equal to 0. And I don't know why I'm trying to cram everything in here. I think maybe we can solve this in this little tiny space. So I'm going to subtract 200 from both sides, equals negative 16t squared. I'm going to divide both sides by negative 16. And that's going to give me a positive t squared equals, oh, looks like I'm doing this. You're going to do it with a calculator. I don't know why I'm doing this all exact. So 200 over 16, give me 1 second. Sorry, I had to go get my calculator. So t squared equals, when I reduce that, you get 12.5. And in this case, when we take the square root, yes, you would normally put in a plus or a minus, but we only want positive time. So the square root of the 12.5, I'm just going to verify that I did this right, is our 3.54 seconds when you round it off. Always try and give 2 decimal places, 3.54 seconds. And that matches up with what the graph says. Now, how far did the object fall between the 2 and the 3 seconds? So we're going to just go ahead and read this from the graph. So at 2 seconds, you're at 136 feet. At 3 seconds, you're down here at 56 feet. So how far did it fall? Well, from 136 feet minus the 56 feet, it fell a distance of 180 feet. Okay, so that would be reading off the graph or using the equation to figure out each individual. So we could have done h of 3 minus h of 2, which is what I was really doing there. Okay, now let's actually set up the equation. So we have a science competition. Students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. We used to do this at Great America on Math Day. Write a function that gives the height in feet of the container after t seconds. And then, so that's going to be our part A. Part B, how long does the container take to hit the ground? Okay, so we know our initial height is going to be 50t. So h of t, this negative 16t squared, that is always going to be there because that's your gravitational constant. Then our initial height here was 50. So there's part A. Now part B says how long does it take to hit the ground? So we know that when it hits the ground, its height will be 0, and we're trying to solve for t. So we set this equal to our negative 16t squared plus 50. In this case, I'm going to add 16t squared to both sides. So 16t squared equals 50. We can divide by the 16. So we have t squared equals 50 divided by 16. And reducing that gives me 25/8. Or since you are going to get decimals, if you wanted to go with the 3.125, that's fine, because in the end you are going to take the square root. Remember, there would normally be a plus or a minus over here, but we only want the positive time. So when you take that square root, second square root, second answer, I'd get 1.768. But what I would also like to do right here is a little bit of a review how to simplify radicals. So if I had 25/8 and I had to simplify that without a calculator, that would be again 25 over the square root of 8. So on top I'd have a 5. On the bottom, this would be square root of 4 times square root of 2. So I'd have 5 over 2 rad 2, but I still have a radical down there. So I would multiply top and bottom, this will become a 2 whenever you multiply a radical. I call them twins. Whenever you multiply two radicals by themselves. So 2 times 2 on the bottom is 4, and 5 rad 2. And if you did a decimal equivalent of that, you would find it equals there. So it's nice to know how to have what we call an exact answer, and also to have the decimal equivalent. All right, there's 3.1.